Hello, and now we are doing question number 19, 3 marks questions from 2011. Okay, this is 2011 question. This question was asked by giving 3 marks. Okay, and it is question number 19 in the year 2011. So the question says, so that every odd integer is in the form of the form 4k plus 1 or 4k minus 1. Solution. So let a be any odd integer, right? A is an odd integer, so a can be written as a, you can write down as a is equal to 4. No, wait, it's odd, right? So you can write down 2q plus 1, right? Odd you are writing like this, right? Even is to write down a is equal to 2q. This is even, this is odd, right? I think this is example question from chapter number 1. You will see this question in example, okay, from chapter number 1, exercise 1.1. There you can see some examples question. There I think you can see this question. So a is equal to 2q plus 1. So q here, q, a is odd, right? But q can be even or odd integer, right? Q can be even or odd integer, same thing, right? So when q is even, we can write when q is even, we can write q is equal to 2k, right? So therefore a is equal to 2 into 2k plus 1, which will be 2 into 2k, 4k plus 1. And when q is odd, we can write q is equal to 2k, okay, minus 1. This is odd, or you can add on plus 1. After that you can find out. Okay, so let me directly use q2k minus 1. So therefore a is equal to 2 into 2k minus 1 plus 1, which is 2 into 2, 2 to the 4, k minus 2 under 2 plus 1, which will be 4k minus 2 plus 1 minus 1, 4k minus 1. So you can write down the last sentence. Let me rough and write down here. Okay, therefore every odd integer is of the form 4k plus 1 or 4k minus 1, right? Now let us do the next question. Question number 20. This question was also asked in the same year 2011 by giving 3 marks. It says state and prove remainder theorem. Very important question. Okay, so this question, the solution to this question is let px be any polynomial of degree greater than or equal to 1. Okay, wait. This question, so that every odd integer is of the form 4k or 4k plus 1 or 4k minus 1, it won't be asked this year. Okay, it is not for 2022 because this time this is deleted portion. Okay, but if you are watching this video for 2023 or 2024, okay, then you can watch. Okay, this may come, but not for this year, that is 2022. So let me do this question. State and prove remainder theorem. What is the statement? Statement I have written down here. Let px be any polynomial of degree greater than or equal to 1, and let a be any real number. If px is divided by linear polynomial x minus a, then the remainder is pa. What you are doing here is, there is a polynomial px, okay, you are dividing by x minus a, okay, and the remainder at last you are going to get is p of a, right? The remainder will be p of a, and here it is q of x, let's say. Okay, let's say q of x, you are dividing by x minus a, and the remainder is pa, such a remainder is r. Okay, so proof, let us start our proof. Okay, px is divided by x minus a, right? Since px is divided by x minus a, so we can write down, so the quotient x minus a, and let qx be the quotient and r the remainder. Okay, then we can write down, how can we write down p of x is equal to q of x is our quotient, right? Q of x into x minus a plus r. Okay, quotient into divisor plus remainder is equal to dividend, right? Now since this relation is true, this relation is true for all values of x putting x is equal to a, we have, okay, putting x equal to a, we have, instead of x we are putting a. Okay, since x can be any number, right? You can put x, the value of x is any number. So what we are doing? We are doing that, let us put x as a. What will happen if I put x as a, p of a, instead of x put a, instead of x put a, okay, so x minus a, so it will be a minus a plus r. This is product here. Now p of a is equal to q of a into a minus a, 0, right, plus r. So I can write down p of a is equal to r. Okay, or we can write down this one as r is equal to p of a. So it says that then the remainder will be p of a. So remainder is p of a. We got this one. So therefore r is equal to pa. This proves the theorem, or hence proved, right? That's all. I hope you understood this one and you get behind this one, understand it, try to understand. You are going to get 3 marks for this question. Now let us do next question, that is question number 21. Question number 21, same year 2011, by giving 3 marks. If alpha and beta are the roots of quadratic equations ax square plus bx plus c, then prove that alpha into beta is equal to c divided by a. Solution. So we know for quadratic equations ax square plus bx plus c equal to 0, for these quadratic equations we know that alpha will be equal to minus b plus root over b square minus 4ac divided by 2a, and beta is equal to minus b, here we are taking plus, take minus here, b square minus 4ac divided by 2a. Okay, now prove that alpha into beta is equal to c by a. So therefore alpha into beta, so let us do multiply these two, minus b plus b square minus 4ac divided by 2a into beta, that is minus b minus root over b square minus 4ac divided by 2a. This question you are going to find in chapter number 5, quadratic equations. There you can find, like, this is proved there. Okay, I think before example there is one article on this. I do not know the page number exactly, but this is from quadratic equations. It is there, okay, given in a textbook. Okay, the solution is also given there. Relation between alpha and beta or something like that. What was the topic? I don't know. Okay, but you can find it out there. Okay, it is there from textbook, chapter number 5, quadratic equations. So if you multiply these two, minus b plus b square minus 4ac minus b minus, So if you take this as a minus a plus b into a minus b, so this one we can write down minus b square minus root over b square minus 4ac whole square, a square minus b square divided by 2a into 2a, 2 to the 4, a into a square, minus b square you can write down as b square minus square and root can cancel. So what's remaining inside is b square minus 4ac divided by 4a square. Okay, this much. B square minus b square, minus into minus it is plus 4ac divided by 4a square. B square minus b square cancel, 4ac divided by 4a square. 4 cancel, a and square cancel, so it is c divided by a. So we got c divided by a, hence proved. Right, that's all. I hope you understood this much. If you have any doubts, please do write in the comment below. Now let us do the next question. Next question, question number 22. I think I haven't completed the question. If tan of theta must be a by b, then so that, let me copy the question, a sin theta minus b cos theta divided by a sin theta plus b cos theta. This is from the chapter of trigonometry. Okay, this question is asked from trigonometry, so you can see this question there, a square plus b square. So solution, take left hand side first. So left hand side is a sin theta plus b cos theta divided by, let me write down properly again, a sin theta plus minus b cos theta divided by a sin theta plus b cos theta. Okay, so let us divide both sides by cos theta. So dividing by cos theta on numerator and denominator, we have, if you divide by cos theta, a sin theta divided by cos theta minus b cos theta divided by cos theta divided by a sin theta divided by cos theta plus b cos theta divided by cos theta, which will be a sin theta by cos theta. So a sin by cos, it is a tan theta minus b cos theta cancel, it will be minus b divided by a sin theta by cos theta, it will be a tan theta plus b cos theta, it will be b. Okay, this much. Now if you look here, tan theta is given to be a by b, so instead of tan theta we can write down a by b. So a into a by b minus b divided by a into tan theta, it is a by b, so a by b plus b. So a into a, it is a square minus, if I take minus b square divided by b square, and downside also I can write down as a square plus b square divided by b square. I am taking b divided by b. Okay, sorry, this is not square down one. This is b here and this is b here. Why? Because b into b, it is b square and downside it is b. So b I can cancel, so it will be a square minus b square divided by a square plus b square, and this is your answer. I hope you understood. If you find any difficulty, please do write in the comment below. And this is equal to left hand side is equal to right hand side, hence proved. So here is our question number 23. Okay, this question was asked in 2011 by giving 3 marks. Prove that area of a triangle with vertices a, x1, y1, b, x2, y2, c, x3, y3 is half into x1, y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So this was the question asked. Now what can we do is, this question is from coordinate geometry. Okay, you can see this one there. So let's draw the diagram first. Okay, let me draw. This is the triangle. Let's say our triangle is like this, and let me draw the perpendicular here 90 degree, here another one, and straight down here another one. And now triangle ABC. So this is ABC. A is x1 y1, B is x2 y2, C is x3 y3, and perpendicular, this is, let's say, PQR. Okay, so this is x-axis, this is y-axis. Okay, from above diagram or figure, from above figure, area of triangle ABC is equal to area of trapezium ABQP plus area of trapezium APRC minus area of trapezium BCRQ. Okay, BCRQ. So what am I writing here? Let me try explaining that. Okay, so the thing what I'm explaining here is this one, the area, this one, right, all this trapezium plus all this area, this one, all this area, right, all this area, this one plus this one minus this one, everything this one, right? So what's left out? If you do this two plus this one and this one plus minus this one, the outcome, the answer will be this one, right? The triangle up one, triangle this one, right? This will be the result outside, right? So ABQP plus APRC minus BCQR, this one will be equal to area of triangle ABC. Okay, so let me rub this one and let's do further. So x2 y2. So I can write down first what is the area of triangle ABC. So area of triangle ABC is equal to half into area of trapezium ABQP. What is the area? You do the plus of these parallel sides and multiply by QP. So it will be ABQ plus AP half into BQ plus AP into BQ plus AP into QP plus area of trapezium APRC. So what will be the area? AP plus RC half into AP plus RC into PR minus half into area of trapezium BCRQ, it will be BQ plus RC into QR. So if we take half common, okay, taking out half common, it will be BQ plus AP. So what is BQ here? BQ means BQ can be straight here, right? BQ, this much, right? This is Y2, right? So in Y axis, so it is Y2 plus AP. What is AP? AP is Y1. So Y2 plus Y1. QP. What is QP? QP is Q to P. What is QP? X1. Here, this much is X1. This much is X2. So X1 minus X2. So you can write down this one as X1 minus X2. Okay. Like this, I can write down everything. So let me write down everything. Half taken out common already. So this one is Y1 plus Y3 into X3 minus X1. And from here minus half taken out common already, so I can write down here Y2 plus Y3 and X3 minus X2. Okay, you can see this one. So it will be half into, now Y2 into X1 and X2, you have to multiply, right? Y2 into X1, it will be X1 Y2 plus Y2 into X2. Y2 into X2, it will be minus Y2 X2, so X2 Y2 plus Y1 into X1, it will be X1 Y1 plus into minus Y1 into X2, it will be X2 Y1 plus, if you multiply this one, you will get Y1 X3 minus Y1 X1 plus Y3 X3 minus X1 Y3 minus Y2 X3 plus Y2 X2 minus Y3 X3 plus Y3 X2. Okay, after taking out all this, I got half into, let me see if I can cancel X2 Y2 and X2 Y2 minus X2 Y2 I can cancel. X1 Y1, can I see X1 Y1 anywhere that I can cancel? X1 Y1, this one and this one, X1 Y1 cancel. X2 Y1, can I cancel anywhere? X2 Y1 I cannot see. So anything else? Y3 X2, Y3 X3, Y3 X3 and Y3 X3 cancel. Y2 X3, Y3 X2 and all this remaining one. So fine, let us write down the remaining one. X1 Y2. Okay, next let me write down X1 Y3 minus X1 Y3. So I have written down this one and this one finish. Next, minus X2 Y1. Okay, next let me write down plus Y3 X2 this one and this one written down. Next Y1 X3 and Y2 X3, so minus Y2 X3. So this one and this one done, right? So half X1, if you take common, it will be X1 Y2 minus Y3, right? And from this 2, if you take minus X2 common, it will be Y1 minus Y3. Okay, or if you take here plus X2 common, okay, it will be Y3 minus Y1 plus, if you take X3 common, it will be Y1 minus Y2. Okay, and this is what they are asking us to prove that area of triangle is this one, right? So we have proved, so this is hence proof. I think this seems a little bit longer, but I hope you understood. If you have any difficulty, please do write in the comment below. Okay, now next, this is our question number 24, same year 2011, asked by giving 3 marks. What is the question saying? A solid metallic cylinder of height 24 centimeter. So there is a cylinder. Okay, let me draw a cylinder. There is a cylinder, metallic cylinder of height. So let me draw, this is a cylinder, and the height of this cylinder is h is equal to 24 and radius is 3 centimeter and recast into a cone. Now this cylinder, okay, what they are doing is they are making into a cone. Cone is something, so let me make cone properly. So let's say this is a cone, this is inverted cone or what. So let me make, okay, wait, let me make proper cone, man. Okay, fine. Let me make this one a little bit longer and let me make, okay, the diagram is a little bit horrible, but fine. Now this cone, now what am I doing is I'm melting this cylinder, making a cone. Okay, cone has a radius of 6 centimeter. So the radius here is 6 centimeter. Find the height of the cone. I need to find the height of the cone. So height of the cone, height is like this, right? So this is h. So let me write down solution. Let h and h1 be the height of cylinder and cone, cylinder and cone respectively. Okay, now let h1 and r1 and r2, r and r1 be their radius. Okay, so therefore volume of cylinder, what is the volume of a cylinder formula? Pi r square h, right? R and h, and volume of a cylinder which will be equal to pi, write down as it is, r square. What is r? A solid magnetic 24 and radius is 3 centimeter. So r is 3 square into h. What is h? Height is 24, right? So you can write down pi 3 square, which is a 9 into 24. 24 into 9, how much? 24 into 9. 9 for the 36, 9 to the 18, 19, 20, 21, 216. So this will be 216 pi. Okay, now let us find the volume of this cone. So let me take a new page. Therefore volume, wait, okay, let me take this page. Okay, let me rough the previous question. Okay, therefore volume of the cone is, so this is our cone, let me find the volume. Therefore volume of cone is equal to 1 by 3 pi r square h, right? Here I am taking r1 as radius and h1 as height. So 1 by 3 into pi into radius. Radius of the cone is given to be 6 centimeter. So into 6 into 6 into h1. 3 to the 6. So this will be 6 to the 12 pi h1. Now the idea is this one melted into this one. So these two, they will have same volume. Okay. So therefore volume of cylinder is equal to volume of cone. So what is volume of cylinder? Volume of cylinder here we got, what is that? Volume of cylinder is 216 pi, right? So volume of cylinder is 216 pi, which is equal to volume of cone, which is 12 pi into h1. Pi cancel. h1 is equal to 216 divided by pi by 12, right? So if you divide 216 by 12, you are going to get 6 to the 12, 6 3 is 18, 6 6 is 36, 2 1 is 2, 2 8 is 16. So you are going to get 18, right? So therefore height of cone is equal to 18 centimeter, right? That's all, and I hope you understood this much. So we have the question only till this much. 3 more questions are asked till question number 24. That's all. If you have any doubts, please do write in the comment below. Thank you so much. We will meet in the next video.